It's in a U.S. Glass magazine. And ultimately what this is describing is jumbo glass. And so it kind of identifies from a fabricator or an insulated glass manufacturer. I think it was a Viracon that was writing the article. So it's kind of an interesting perspective that they had about jumbo sizes of glass. And so in it, they identify some different things that I really wasn't aware of. Some of the things I've highlighted, there's other things that I was aware of, but ultimately what they're describing is the jumbo sizes, which we get into a little bit later down here. It's important that they have a spacer that actually will handle the atmospheric loads. And so this part up here, it's kind of whited out, but it ultimately it describes that the spacers that they use can vary from aluminum to stainless steel to a thermoplastic. And ultimately they need to have those spacers fluctuate with the atmospheric changes to be able to stay in place. So here's where we kind of get into some of the stuff that's really unique that I've never heard before. They indicate that at Viracon, an aluminum box spacer can be used for up to 120 square feet of insulated glass, and a stainless steel box spacer can be used for up to 70 square feet. Above those sizes, thermoplastic spacers are needed. I wasn't really aware, of that issue, the need for thermoplastic type spacers. They indicate that Viracon's thermal spacer, which is called VTS to them, is the primary thing that they use in the sizes that are above 120 square feet. They have this quote here: "The reason you cannot use a box spacer for sizes that are large is that metal spacers, due to their weight and size, are difficult to manipulate." So fabrication issues are the controlling reason in the jumbo sizes that they have to use a thermoplastic type of a spacer. The weight causes the metal to bend and kink during the fabrication process. Didn't know that. They also made reference to a unique spacer that I think I briefly heard a little bit about. It's called Techniform TGI Spacer M. It's actually a bendable warm edge spacer bar which can come with a wire to add stiffness. Now, to me, that's really weird. Any comments or thoughts about that? To me, what that indicates is that, somehow they've got a post-tension type of an application for a spacer to add stiffness. I've never heard of that.
Or it's just embedded in the spacer, kind of like rebar in concrete. So when it goes into tension, that wire's taking that.
Maybe it's not adjustable, but it's interesting that they've mentioned that. I've never seen a wire that's actually, in a detail that shows that it's inside of a spacer, but I thought that was really kind of odd and interesting.
Because most of the flexion on that glass would come at the center of glass, right? I mean, the edges are supported by aluminum. You would think that they might not need that much reinforcement.
Yeah. So I'm kind of curious as to why it's needed. Number one, is it part of the process that they need to have it in place to add stiffness so they can ship it and install it? That might be a case, but they really didn't spell it out. It goes on to say that a thermoplastic spacer can be applied directly to the glass in an automated process, which creates a more uniform look. Traditional box spacers require a PIB sealant, which Lawrence says never fully cures and can flex under wind loads. VTS forms a chemical bond rather than a mechanical bond. Once it cures, there's no movement. Okay, another odd statement. What's your take on this?
I'm kind of curious, are they talking mostly about SGP applications, or like when you're moving the glass, do you only lift it on like one panel and then you have to rely on the spacer to take up the load of supporting the other panel? Is that what they're talking about? About the concerns about spacers not being strong enough and the metal spacers potentially bending or kinking?
I was taking the previous conversation that they had up in the previous paragraphs about the kinking and the bending as being a more of a fabrication issue associated with the spacers. Because of their weight and size, they're difficult to manipulate. The weight causes the metal to bend and kink during the fabrication process. So I was thinking that that was more of a fabrication issue, but you know, this down here is very curious. And I've never heard of this VTS forming a chemical bond with the glass. And ultimately, this fabricator is saying that there's no movement.
Well,
Your other thoughts? Go ahead.
Don't all spacers form a chemical bond?
Well, I guess that, you know, the PIB would be more of a adhesive bond versus a chemical bonding. Other thoughts?
I do know, I've seen, like, when I was doing some of the thermal review and studying, when we were kind of, you know, looking into that, I suggested warm edge spacers on a couple of those jobs just because I ran across it. And I know the architects at that time, they were kind of new, I guess, and they were ugly. And so they kept pushing them off. But I mean, it makes sense that, you know, like we talked about last week, center of glass is your best area. And then they've been improving the frame with thermal breaks, etc. And so now you know, it's time to keep, I know the edge of glass has always been something that they bring up whenever I'm reading into it. So it makes sense that they're working on things like these, I guess, but these are interesting.
Yeah. One of the things that this brings about, you know, a question in my mind is that, you know, I understand that this is a fabricator, but he's saying, obviously, because of this chemical bond, rather than an adhesive type of a bond, he's saying it obviously really stiffens it up. I wonder, you know, if it's a very rigid bond, whether there's a different potential deflection requirement that we need to adhere to, because, you know, we're used to the 3/4 inch edge of glass deflection criteria. But if we let it move more, is there a possibility that that chemical bond, if it's rigid, can be broken?
So looking at Vericon's website, they say the same thing. VTS is a proprietary formula consisting of black thermoplastic integrated desiccant, is chemically bonded directly to the glass and secondary sealant.
Yeah.
Replaces the traditional spacer and all that other stuff.
Okay.
So is it basically like it's laminated to the glass versus the other one is laid in and essentially glued to the glass via the secondary sealant?
Well,
yeah, saying it's chemically bonded makes me think it's something more like adhesive, like that permabond stuff we just used for that rail.
Like it reacts with the glass and fuses with it.
Right. Something along those lines where it chemically reacts with the glass and creates a different layer there. The PIB is a polyisobutylene, and so this has been used in IGU units forever, you know, in terms of the primary sealant. And so the primary sealant is the one that is directly between the glass and the aluminum spacer, or whatever the spacer is. And it's actually the one that prevents the gas or moisture from intruding inside of the IGU unit, or the gas that's on the inside of the IG unit from escaping to the atmosphere outside of it. So they're talking about something in lieu of that that's a VTS chemical type of a bond that's proprietary, and it definitely looks like it creates more of a stiff interface. And I'm thinking that, you know, along with that stiff interface, there's questions of how much do we allow the edge to deflect? Because under the old, we were able to allow it, you know, three quarters of an inch of deflection. Does that make sense?
Yeah. Is that something we should reach out to them and see if they have testing on?
Yeah, I guess if we ever have any of these really large glass panel projects, we might want to be aware of this to kind of understand what it is that they're doing. If we get the responsibility of the insulated glass unit design, it would be a critical item for us to, but it sounds like they have some very specialized people on the inside of their company that does this type of design for them. I don't know. And I don't know if they're, you know, if they're required to seal it, but I would hope so.
What are they considering large lights? Are we talking like 10 foot by 10 foot, or do they actually list what the jumbo glass is?
Yeah, so anything for Viracon, anything that's larger than 120 square foot, so 10 by 12, you know, that would be encroaching on that large glass size.
So my thought in all of this is, okay, yes, there is limitations to the actual, you know, spacer, but for that large light of glass, do we still maintain the minimum 5/16 secondary sealant bite? I mean, to me, that needs to be increased to a minimum of maybe ½ inch, just for a little bit of a buffer. Because I mean, you're talking a large light of glass at this point.
Veracon's website says it can be used for up to 130 by 236.
130 by 236. So
that's a little over 10 by 20, or almost 10 by 20.
Wow.
Does it say anything about the secondary sealant limitations, Brian?
Yeah,
like if it needs to be a minimum 3/8, ½ inch, or anything?
It's just like a sales page on their website that lists different spacer sizes and U-value stuff. There isn't even a tech sheet on it.
I'm just thinking, if I have my PE and I go out into a field and I'm looking at a light of glass that's 10 by 12 and the secondary sealant's only 5/16 of an inch, I'm probably gonna look at that and question, is that right? You know.
That's only if it's SSG type application. In other words, if it's structurally adhered to the aluminum frame, we're worried about the secondary sealant and its depth and its thickness and its design to handle the wind loads being transferred through it. If it's captured, it's not really a big deal, I would guess. Reading on, associated with this article, it says, edge of glass U values are improved when using a thermoplastic or other warm edge spacer compared to the traditional metal box spacer. In addition to its other benefits, argon retention is about 30% better with thermoplastic. So ultimately what they're driving at is that with the larger and larger glass sizes, architects are pushing forward for better thermal values, and you know, the argon is obviously an item that gives them better thermal and also better noise values, I think, too.
Yeah, I was gonna make a comment on that from Juan Pablo's presentation last week. Remember that a larger IGU with less framing and edge of glass components will have a better U value. Sorry, the other way around. A smaller IGU with more framing and edge of glass components on their area will have a poorer thermal performance, like as far as the U value is concerned. Whereas this huge areas of glass, your center of glass is so predominant on the area of the frame that it mitigates the much poorer performance of edge of glass and of the framing itself. So it's kind of like you want to make this center of glass as large as you can. Well, the architects want to make that as large as they can so that they can counteract the U values for the frame and edge of glasses.
Yeah, yeah. The article also points out that that these are showing up in a lot of podiums. You know, wherever we have large buildings, the podium part of it, these types of insulated glass units are showing up.